Hey everyone, how's it going? I'm Meteorologist Kylie Bearse, and today we are talking about one of my favorite topics, thunderstorms, and more specifically, we are talking about lightning, which as always looks so cool when you're able to watch it from a safe distance. So let's first talk about how lightning happens, what makes it happen in the first place. So here's the deal. Here's kind of a look at a thunderstorm, that big cloud that we see there. Now we know that clouds are made up of tiny little ice droplets and ice crystal or water droplets and ice crystals. And so what happens is inside of this thunderstorm, we've got a whole lot going on. There's a lot of wind, and all of those ice crystals and water droplets, they start to kind of bounce into each other. And as they do, they create this electric charge. And with that, all the negative charges tend to go to the bottom of the cloud and the positive to the top. And as we know, opposites attract. And so with that, once that charge gets big enough, we finally get to see them connect, and that's when we get the lightning. So when you were actually to slow down lightning, I know it happens so quickly, it's so hard to see, but this is how it actually formed. It kind of comes out almost like tree branches when you're looking at it. Really cool to see kind of how that is when you're breaking it down like that. But here's my favorite fact about lightning. This is so cool. The strike itself is only 1 inch wide. That's it. And it's that big. It has that much power, and you can see it for miles and miles and miles away. So it's just remarkable that something so small, only an inch in diameter, is actually, or only an inch wide, I should say, is able to create that much force. So here's a question for you. Is lightning hotter than the surface of the sun? Give you a second to think about it. I mean, the sun's pretty hot, right? You wouldn't want to go up and poke your finger in the surface of the sun. You wouldn't go very well. But if you said, yes, it is, you're right. It's about 5 times hotter than the surface of the sun. Lightning can get up to about 50,000 degrees. So that's, of course, why lightning can be so dangerous. Now, this is a really cool map. Check it out. So these are the lightning strikes that happen all over the entire world. Here we are in the United States. There's Africa. So we've got all the different continents. These are all the lightning strikes that happen all over the world in a year. And so every second, so every single second, a second just went by, somewhere in the world, about 50 to 100 lightning strikes happen, which is just remarkable. So what does that add up to every year? 1.4 billion lightning strikes. So they're happening all the time, and you can see some of the hot spots are when we're looking at Central Africa into parts of South America, and the lightning hotspot for here in the United States, that's over Florida. Now in Colorado, we get about 500,000 strikes per year. So we get a lot. That's about 19th in the country. But one of the reasons why we have a lot of deaths that happen from lightning strikes is because we do have a state where people love to go outside. So we've got a lot of that danger that happens there. But 500,000 strikes per year here in Colorado. Now, if we get some thunderstorms and we're kind of moving into that season, you can actually tell how far away a thunderstorm is by just counting. It's really easy. So when you see lightning, you start to count. You go 1, 2, 3, 4, and when you get to 5, that means that that thunderstorm is exactly 1 mile away. If you get to 10 seconds, it means it's 2 miles away. So you're actually able to do that because we see the lightning first, and then the thunder is a little bit slower because that travels at the speed of sound. So it takes 5 seconds to travel a mile to get to you. So you can actually tell how far away you are. Now, one of the myths that comes with lightning is that it never strikes in the same place twice. I don't know about you guys, but I always grew up hearing that. Well, it's not true. And in fact, it's always kind of looking for that tallest object and looking for that easiest pathway to get to the ground. So the Empire State Building, one of the tallest buildings, they actually get about 25 to 100 times that they're hit by year by lightning, which is just crazy when you think about it. They've got a little tower on top there that'll take in that lightning. So now it's kind of a fun experiment that you can do at home. We got a couple of different things, and all you need is a balloon. So go ahead, if you guys have a couple of balloons ready to go. And one of the fun things that you can do with it is just starting off with giving yourself a really bad hair day. So you can rub it on your hair, make a really big mess, rub it a lot, and we are creating static electricity. So as I pull it away, do you see my hair? It's sticking up, and it now looks really bad. We'll do it again, right in the front. And so you rub it, and then you pull it away, and you can see all of that static electricity. And so what happens is when you're rubbing, there you go. When you're rubbing it on your hair, you're creating a bunch of little tiny electric negative charges. And we know that they all don't want to be together. And so they're going to kind of spread out a little bit too. And one of the cool things you can do is you can rub this and rub this and rub this, and then rub it for a few seconds, and you can actually stick it to a wall, and it'll stay there because of that static electricity. The wall has those positive charges, and then those negative charges are what you're creating. Now, the really fun part, let's talk about thunder. So when it comes to thunder. Can you have thunder without lightning? Think about it. Yes or no? Now the answer is no. You can't have thunder without lightning because lightning actually creates the thunder. And so we can create our own thunder with your balloon when you're done with it. Oh, here's my little pin. Got it? Okay. So we have our balloon and we have our pin. Now the two of these, they don't make any noise on their own, right? Maybe if you kind of move the balloon around. But what happens with thunder is when that lightning strikes, it expands air so quickly, it makes a really, really loud noise. So we are going to expand air out of this guy very, very quickly. And how do we do that? By popping it. Okay, everyone, just a warning, it's about to get really, really loud. But we can make our own thunder by going... So you can make your own thunder once you're done playing around with the static electricity. It's a ton of fun. All you need, again, that balloon. And if you are playing with a little thumbtack, make sure you've got mom or dad's permission before you do that. But all of that thunder is just air expanding really, really fast, just like if you were to pop a balloon. All right, everyone, have fun. I've got more balloons to play with, more static electricity, bad hair days to make.